ice stupa artificial glaciers, what we attempt is to freeze water in winter when nobody needs, and still a stream flows, goes into the Indus, goes into the Arabian Sea, is not useful anybody, useful for anybody. So we pipe the water from those streams way up in the valley. For this one, it's 2.3 kilometers away and 60 meters above. So it's upstream and away, or we bring the water downstream and on the desert where we want to plant trees. So in December, January, February, when there's still water in the stream but nobody needs it, the piped water is brought downstream, and it's very simple high school science that water wants to maintain its level in a pipe. So that's 60 meter high. Here in the pipe, water will want to go to that height. There is a pressure to go to that height. So we take advantage of that and put a fountain at the tip here. Now there is pressure, there is a fountain, so water will be splashed into the air, into the minus 20 air, which is very cold. So you would also wonder why water doesn't freeze.
Because
in this
temperature.
Pipe. So temperature is minus 20, and the water in the pipe should remain above zero. Otherwise, it will freeze right in the pipe, and no fountain will work.
So how does it flow?
So what we do is we bring the pipe underground. Underground, roughly 4 feet and below, nothing freezes. So it's below the frost line of the area.
I see.
So when you bring the pipe underground, it's just above freezing point, just about to freeze, but not frozen. Therefore, we can use the properties of liquid, of water, liquid properties of water, and make it flow itself, and then make it rise and splash into the air, spray into the air, and there it loses that critical heat that keeps it liquid, which is called latent heat. High school science. So it loses its latent heat in the minus 20 air, and then when it falls down, because it has lost that critical heat, it freezes. It freezes, and slowly it takes the shape of a cone. That's natural. When water falls, trickles in drops or in a fountain, it naturally takes the shape of a cone, a big cone. And cone is one shape in geometry, one of the shapes that has minimal surface area for the given volume. Spheres, hemispheres more practically, and cones have minimal surface area for the volume, and that makes it last late into the spring or almost summer, right? Because of this conical shape, the ice stays till April, May, June. When all other flat ice on the ground is gone, this one stays. For example, this is now mid-June. There still remains of the ice stupas, and it has gone, but that's the purpose. It was 80 feet tall.
This thing was
80 feet tall, and now it is like 15 feet, but that's now mid-June. It should be actually now gone, and it has lasted longer than what we expected. So every day as it melts in May, June, April, it's giving its water to the trees down below, as we'll go and see. In the winter, we make first a tunnel of this shape with metal and plastic, and there is a dome inside which is now restricted, and then with that dome we control the making of it, add pipes to rise and rise as the ice forms. So that's the making of it. Right now it's morning, so the ice is not melting. If you come here at 2, after 2, then there will be a small rivulet flowing, as the ice melts, and then it's so designed that it will all collect here. Water will all collect here, and from here into the tank. It has been used for watering, and at like afternoon it will still be filling, and then somebody uses. So from here there is a drip irrigation system. This pipeline goes all the way to the bottom. So there is a sort of a spine, and then ribs. The only thing that's stopping that desert from becoming green is not water per se. It's the water in April, May. Because June onwards there is water, but that's too late for, it's too late in the summer.
Yes.
No plants can survive
till
with
then.
water only in June.
Yeah.
They need it in April, May, when they wake up.
Yes.
So that's what we are trying to give with the ice.
So giving them the water when they need it the most.
Yes,
is
yes.
the
And
key.
then giving them later also, but from the streams that flow naturally. So there are two projects. That's why this pipe, to scale it up. We wanted to see how it works and then only scale it up. So now that these trees have been doing well for 3 years, so the pipeline lines are being laid and we are seeking support to further green the desert.
Yes.
For the university and for the people. And we are also doing various glaciation projects high up in the valley, in the Phyang Valley, near towards the glacier itself, so that all winter water in the stream can be frozen, and then it will melt in April, May and enhance the stream flow itself, which will be good for the villages also. This one is on the desert, a pilot, but doing it in the valley will help all the farmers.
But this really looks amazing, and that's waiting to be done.
Yes.
I can only imagine green there.
Yes, because if 5,000 trees can be done, why not 50,000? Why not 5 lakh?
Yeah.
As long as there is the limit for greening is not the land, it's the water that flows in winter.
Yes.
If all of that is frozen, then much of it will be green.